Hello everybody! I decided that I was going to make a chill video today. I've been working on this video interface for quite some time. The unfortunate reality of this is the fact that I have completely built this circuit on breadboards about 5 times now. It almost works, but unfortunately there are still some issues with the timing on both sides. I was following some schematics online, but I guess that they didn't quite work out for me. I'm honestly confused on how it worked for the person who made it. Anyway, I figured that I would design it out with this program Logisim. Obviously, many people have made a variation of this circuit already, but I need this to work with the computer that I am making. Luckily, it shouldn't be too hard, so let's go ahead and get into it. When I was designing this, I did my best to try and reduce the amount of chips I needed. Whether I actually succeeded is still unknown. The good news is that the logic is quite easy to understand. I broke this up into 4-bit sections and I titled them things like LM1 for leftmost 1, MM for middlemost, and MS for most significant. Don't ask why I chose LM instead of LS. While designing, I went between where I should place my IOCs. The original design from a few months ago only takes 3 breadboards. Unfortunately, my new design will take 5, which is a little upsetting. Now that the HSync is completed, I think now is a good time to take a short break. I would like to talk about this video sponsor, Ivan. If you are in need of a PCB, Ivan has a great promotion going on. If you haven't ordered from Ivan before, then you are likely eligible for $60 in PCB prototyping credit. With these discounts applied, your prototype can be as little as $1. So not only that, but they make sure that every board works. Every board at Ivan is inspected and undergoes rigorous stress testing to ensure that you get the quality that you deserve. So, if you're looking into making a more permanent prototype of that breadboard project of yours, maybe try checking out Ivan. If you would like to purchase a PCB, please make sure to use my creator link in the description below. Thank you, Ivan, for being the sponsor of this video. Well, now that the HSync is done and working, it is time to get the VSync created. I'm first going to design this similar to the HSync. Luckily, this is pretty much identical to Bin Eater's implementation with just a few tweaks. What I like about this circuit is that it reads everything at 10 bits, but 2 of the bits aren't needed, so I can use the 70LS30 for each VGA line. Why don't we have a 10 input NAND gate IC? Honestly, an 11 input NAND gate would utilize every pin. Oh well. When designing this circuit, I could have gone with the same route as the HSync circuit and used the 4-bit design, but the 8-bit route was a bit more simple, with using the 74LS30s. And it used the same amount of ICs, so might as well just go with the 74LS30s. Okay, so that VSync Tablax was so similar, but I did want to show it working. So the last part is connecting the two. I tried to make the chips more visually pleasing, but it unfortunately wasn't working properly. Maybe it was a bug in the software, but I'm unsure. Anyway, I wanted to be the most efficient with the RAM and video data, so I'm just doing a black and white for now. Maybe I can make a few modules where if I need color, I can swap out the video interface to support the colored programs. So anyway, I was left with a few options. I need a whole RAM address, which is 16 bits to represent 16 pixels on the screen. And I had 2 ideas for this. First, I could use a 16:1 mux. I did some research and it seems like it will work fine, but I really do like to get a little adventurous. My second option was to use a shift register, which has an added bonus that it operates a little bit more quickly than a 16:1 mux. I haven't done a whole lot of research on this, I honestly came up with this myself, but I think that this could work. Every 16 bits that have been counted on the HSync, it will load the next RAM address. The last bit on the shift register is what will be read for the VGA pixel data. With every tick of the clock, it will read on the VGA, and then the shift register will shift down one, loading the next value in place for the VGA to read. Once all the data has been shifted out, the shift register will load the next address in RAM. It's one thing getting this to work in a simulation. I of course need to get this built in person. I unfortunately was short a few ICs, so I didn't get this built for this video, but I think that you may have an idea on what the next video's topic may be. Once I'm done, I would love to play around with some color variations and maybe get some PCBs made of the various interfaces. But in the meantime, I hope that you all enjoyed the video. I know this video is a little bit different, but I figured that some people may enjoy watching my design process. With that, I think we may be nearing the end of this video. Once again, I hope that you all enjoyed. Don't forget to check out the sponsor link in the description below. Bye bye!